A boat is moving with uniform velocity, it is given, pulling a water skier with the help of a tug rope of length L. To increase his speed, the water skier tilts the skis slightly away from the direction of motion of the boat. As it does so, the tug rope rotates. And what is the speed of the skier with respect to the ground and angular velocity of the rope? And given these two angles. Okay. So in this question, this is rope. This end moves with boat. It's having velocity 20 as given. This end is connected to skier, which is moving with V skier, making an angle 60. Now we are resolving these velocities, both these velocities, along the rope and perpendicular to the rope. So the component of Vs along the rope will be Vs cos 60 and perpendicular component will be Vs sin 60. Similarly, this velocity will have components as 20 cos 30 and 20 sin 30. Now, since the rope is tight, uh, this implies that this end and this end must move with same velocity in the direction of rope, in this direction. So it means that Vs cos 60 must be equal to this velocity 20 cos 30. If a rope is tight, its two ends must move with same velocity in the direction of rope. Otherwise, rope will either slack or it will break. Suppose we have a rope like this, and this moves with velocity 2, this moves with velocity 4, different velocities. Then obviously this rope will slack. And if it happens otherwise, if this end moves with 4, this with 2, then obviously it will break from some point. The rope will break. So if it isn't slacking or if it is not breaking, then the two ends must have same velocity along the length of rope. So this implies Vs cos 60 should be equal to 20 cos 30, and solve for it. Vs cos 60 is half, 20 cos 30 is root 3 by 2. So this will give Vs. So this is first part of the question. The second part of the question, consider the velocities in other direction. So that is 20 sine 30, so which is numerically equal to 10. And the other velocity perpendicular to the rope is Vs sine 60. Vs we have already found, 20 root 3 into sine 60. So this is coming out 30. So the two ends have these velocities perpendicular to the length of rope. Suppose this end is A, this end is B. Now relative to end A, B will have a velocity, its own velocity 30, and a velocity opposite to the velocity of A, that is 10. So this is the velocity as seen by A. This will be the velocity of other end. A will find the other end to be moving with a velocity of 20 meter per second, and A will see that B is moving along a circular path. This is as seen by A, because A will find itself as rest, and if the string is tight, then the only possible path is a circular motion. And in circular motion, we know that V is equal to R omega. So here R means L. So put this value. L is given in question as 10. Omega will be 2 radian per second. Like this. Okay.